Okay, just going to do another one off the back of one of the other videos, so hopefully I'm not too whacked out of it to be able to do this properly. But this one again is only for honours leaving cert students, so it's only going to be for anyone who's doing the honours leaving cert. Anyone else, you can go. Don't worry about it, you'll be fine. You'll come up against it at some point in your life, I'm sure, but not today. So what we're doing here is it's called the factor theorem, and the idea is that this is an x cubed. Now, when you do an x squared, if they ask you to find the roots or the solutions, roots and solutions are the same thing. For a quadratic, we have two methods. We either use the minus b formula, or you can do the brackets kind of factorization way, but I'd advise you to do the minus b. For a cubic, so for a quadratic, we'd get two answers because there's a squared on the x. The biggest power on the x will determine how many roots are there. So because there's a squared on an x in a quadratic, that means there's two answers, and that's why when you do the minus b, you get two different answers. However, for a cubic, such as the one I have on the screen, the biggest power is a 3, so there will be 3 roots or 3 solutions. Also 3 different factors, so they don't have to be different. I take that back. But 3, right, that's the important thing. Now, there is actually the equivalent for an x cubed for a cubic that we have for a quadratic, in the sense that there's a minus b formula also for a cubic, but it is way too big and way too long, so we don't actually use it. We don't put it into the log tables. It's not used, right? It's just, you can look it up yourself. It's actually horrific, but there's a square root instead of a cubed root. It gets weird, right? Don't indulge it. But the idea is that, yeah, this is 3 roots, and because it has 3 roots, it has 3 factors. So what we're going to do is, our aim is that we're going to find one of the factors and divide it in using long division. And when we divide in one of the factors, what we'll end up doing is cancelling it or breaking it down. And we'll end up with a quadratic instead. And then you would do the quadratic with a minus b formula, let's say, and you get the 2 other roots flat out that way. So it basically all stems from the idea that this guy can be rewritten as its 3 factors, like let's say x plus 2, 2x minus 3, and x minus 1. I don't know what they are, right? We're just spitballing here. But if I divide that by x plus 2, which would be the same as dividing this by x plus 2, what would happen is this would get cancelled out, and we'd be left with 2 factors. So what would happen is this guy would turn into a quadratic of some sort. Yeah, no, again, I don't know. I'm just making this shit up. Don't take that right down at all, particularly with the x. But that's the whole idea. We're going to cancel out one of the factors, get left with 2, and then do the minus b with this guy to break it down into the 2 brackets that are left. That's the concept, right? Now, there's a couple of sticking points at the start. Once we get into it, though, the maths is going to be fairly, I don't want to say easy or handy, because I know that's going to rub some people the wrong way. But what I mean is, it's nothing too complicated with regards to a lot of the maths that we're going to use here is maths you've been doing since junior cycle. Again, not easy. If you find it difficult, don't get too weirded out or fearful of it. And don't forget that you get a lot of the marks for just doing the method correct. So even if you get to the very end and the answer is slightly like a weird number, don't get too annoyed or with yourself, because that's only losing like 2 marks. Try your hardest not to do that, but do not get to the... A lot of people are like, oh, well, this is actually getting me weird numbers, so I'm just going to stop. Don't do that, for the love of God. Unless you know that you've clearly fucked it up. Like, if you're doing this and you bring in, like, Pythagoras' theorem or something, then maybe I give you permission to drop it. But if you're in the exam and you get, like, minus 17 over 96, that's probably not right. Doesn't matter. If you're doing it the correct method, keep going on. You probably just scuffed up a minus or a plus somewhere, and then as a result it all kind of cascaded out of control. It might just be that the leaving cert's fucking with you. That can happen too. But I've been talking a fair amount of time without actually doing the question. The point I want to make is, though, you notice a lot of these questions now will say, show that x equals minus 3 is a root of this, right? How you show something as a root is, keeping in mind a root or a solution is how many, or where it crosses over the x-axis, unless we go into complex roots, but we're not going to. So it's where it crosses over an x-axis. Kind of like the graph I have on the left here, right? But that's for the next question. You notice a cubic will hit it 3 times. That's what just 3 roots, and we're going to talk about it. They told you in this one, well, they didn't tell you. They kind of said show that it is a root. So they're kind of just being like, just make sure. And what a root or a solution, because it's where it crosses over the x-axis, it means that if we sub in minus 3 everywhere we see x here, right? we should hopefully get 0 over here. And then we'd know that the point minus 3 comma 0 would be on the graph, which would make sense because minus 3 comma 0 on the graph would be here, and it would be a point on the x-axis, and hopefully be in a way that like the cubic goes through it. I know that line doesn't go through it exactly. Don't at me. Don't do it. That's what we're going to do. We're going to just, the first bit, to show that it is a root of fx, not even reading the and bit just yet. Just sub it in everywhere you see x. So I'm going to have 2 times minus 3 cubed plus 5 times minus 3 squared minus 4 times minus 3 minus 3. What's that going to be? Minus 54 plus 45 minus plus 12 minus 3. And I'm going to tell you that does equal 0 because it'd be 57 and minus 57. So that's happy days. So therefore, x equals minus 3 is a root. So we can say one of our roots is x equals minus 3. Now, they kind of said that so much by saying show that it is a root. So they're kind of saying it is, but just prove to us that you know how. Yeah, and the reason why we do that is because that's the root. So that's one of the roots. That's actually one of the answers effectively. But don't forget, for every root, you can change it into a factor, or vice versa. If you had a factor, you can change it to a root. And what you do is you basically, the root is where it's x equals, the factor is where it's equals to 0. So you'd have to bring the minus 3 across and make it a plus 3. And that would be the factor form. That root and that factor both stem from each other. One is a root, one is a factor. Root x equals factor equals 0, right? Now, the whole purpose of that is because now that we know one of them, we can carry on with the whole factor theorem idea I was kind of literally like trying to explain earlier, where I drew all that other shit in. And it's the idea that we can now divide that cubic by x plus 3. I'll do it over here, I guess. I'm trying to think what would be the best way of writing it, because I know it might look weird order afterwards at the end. I know you're seeing me do it step by step, but if you just skip to the end like some sort of lunatic, it might look weird in a weird order. So we're going to do this long division here, because remember I said that cubic is like 3 factors. We have found one of the factors because we found one of the roots and just kind of reversed it. So when we do the long division here, we should get a quadratic. Now, I'm not going to go too intensely into how to do the long division because there's a video on that, right? So I don't want to get too bogged down into it. But basically, this would be 2x squared, 2x cubed, plus 6x squared. Draw a line, change the signs. Boop, boop, cancel. That becomes minus x squared. You bring down the minus 4. X, this would be minus x up here. This would be minus x squared, minus 3x. Draw a line, change the signs. They cancel. You get minus x, minus 3. That would be minus 1. That would be minus x, minus 3. Draw a line, change the signs. They cancel. Yay. This is the answer, though. Don't forget, this is your boy that we're going to look for. So the cubic had 3 factors. It was made up of 3 factors. We knew one of them was x plus 3. By doing the division, we kind of cancelled that one out, and we got left with this. And that guy is the 2 other factors that were left behind. We got rid of the x plus 3. We just don't know what the other 2 factors are yet. And how we do that is we take the 2x squared minus x minus 1, and we do the minus b formula for it, right? Is that right? That looks weird. Yeah, now you do the minus b. I'm going to do the brackets, but I swear to God, if you don't do the minus b, I'll hunch us all down, right? Because then it's going to be 2x, x, 1, 1. It's going to be minus plus, I think, right? And then we're going to do it like that, because I should have put that. And then we would have x is equal to minus a half, and x is equal to 1. Now, those are the answers. That bit there and that bit there should be the answers you get to the minus b formula, hopefully. And those would be your 3 roots. Now, it said the other 2 roots, so that's that and that. If it had said all 3 roots, we'd have to remember that we also know x equals minus 3 is one of the roots. And that should be your boy. That should be the question. That's what they want you to do. Now, I skipped a few lines and glossed over a few things, but I'm kind of hoping that at this point you'll be okay with doing the algebra to it, or you'll be able to find a video that I have done, for example, the long division on, and you can kind of refresh yourself on that if you're a bit stuck on it. Okay? I'm probably going to go pause this, going to put this in the graphing app, and just show you that it does in fact hit the x-axis of those 3 points, just to confirm. Hey, look at that magic! It just showed up for you guys. Wow, so talented. Look, you notice it crossed over the x-axis at 1. That looks to be minus a half, and minus 3. 1 minus a half and minus 3. There you go. Happy days. Now, I will just say, we were lucky because they gave you this one in the original, where they gave you one of the original roots at the very start, where they said x is equal to -3. They won't always do that. It's more of an older thing, and you might have seen it if your teachers will sometimes try get exam questions from previous years. They know you'll have seen the most recent ones, or will be able to find the answers very easy. So what they try to do is they pick ones from like very far back, like ancient times, like all the way back in 2012. Like, oh my god, imagine. And what they'll try to do is they'll try to give you questions from there. But the problem is, it's the same concept. It's still the factor theorem, but the problem is, I know us old people say it used to be harder back in the day, but it was. I hate to tell it, like, you guys will doubt that. But it was because they didn't give us one of the roots at the start. We had to guess it. So it would literally just have been, this question would have just been like, my pen kind of died out there for a second. It would just say, here's the cubic, find the 3 roots. That's what it would say. And we wouldn't have the first one to guess, right? So we wouldn't have had to do this part where we sub in and get it to be 0. We wouldn't have to do that. That's fair. But we wouldn't know what to do for the long division. This would just be still a question mark for us. We wouldn't know. So what we would have had to have done is we would have had to take the original cubic and just keep subbing numbers in for x. We'd have to say, oh, what about if x is 1? And then sub in 1 everywhere you see x, right? So we do 2 times 1 cubed plus... And I'm not telling you this just to be like, yeah, well, my life was tougher, you know. I'm literally just, in case they do hit you with this, I don't think you guys are as well practiced on it. I don't know whether they're going to do it. But you'd sub it in. Now, you'll notice that because, weirdly, I picked 1 and 1 is one of the roots, it will actually work out. Because you'll notice here, we would get +7 minus 7, which is equal to 0. And you go, oh, well, geez, x equals 1 is a root. Therefore, if x equals 1 is a root, x minus 1 is a factor. And I would do the long division with x minus 1 instead. And it would have worked out the same way. Just the quadratic would have been different. And when I did the minus b, instead of getting -1/2 and 1, I would have gotten -1/2 and -3. I would have gotten the 2 factors that I didn't use. And that's what we used to have to do. So if that comes up, if they don't give you one to start with, you just guess the first number. You keep... Now, I was lucky that I just picked 1 because 1 is the first number I thought of, and it just happened to work. But when we used to do it, it might have been guess x equals 0 or guess x equals -3, guess whatever. I will tell you the hint for it is, it always has to be a factor of this number. So the factors of 3 are 1 and 3, or -1 and -3. Don't forget they also count in this. So you'd have to try those 4 until you found one that does give you 0 at the end, like we got down here. And once you get that one, then you jump to the long division. You know what to put in this place here, and you do the long division there. And as I showed you, it doesn't actually really matter which one you do, because they gave us the x equals -3, which I turned into x plus 3. I did the long division, I got a quadratic, I did the minus b, I got that. But if I was to do it the old school way, and I sub in 1 and it works, and I say, oh shit, that's crazy, well, that means x minus 1 is a factor, so therefore I can put the long division with x minus 1. That would also work. I don't think it'll come up for you guys. I just wanted to point that out to you, that if it does come up, just be warned. I'm going to jump to this one just because it's simpler, I guess. We saved the best for last. So this one is actually a lot easier, because not only did they not give you... they didn't give... Okay. So they didn't even give you the first root and you had to change it into a factor. Or, well, they didn't give you a number that you had to prove was a root and then change it into a factor. They literally just gave you the factor. Find the 3 values of x for which fx is equal to 0. Well, if x plus 1 is a factor, as we said, that means x plus 1 is equal to 0. That would be the factor. But as I said earlier, you can change from a root to a factor and a factor to a root. So what you could do here is just rearrange that to x equals -1. Just literally bringing the guy over here instead. Or just swapping them back and forth. So that's what. So find the 3 values of x for which fx is equal to 0. One of them is -1, so that's one of the 3 done. So that's now 2. Find the 2 values. We already have one of them. Okay, so now I'm going to do long division again. Just do x plus 1. Maybe I should have started with this one at the start. It's too late now. I'm not doing it again. Just be a waste of my time. 40x plus 63. But then we do the whole long division thing again. And we're going to have a grand old time with it. You better be enjoying this. Or else. They cancel. That's minus 23x squared. That'll be plus 40x that we bring down. That makes this minus 23x. That makes this minus 23x squared minus 23x. Draw a line, change the signs. They cancel. This is 63x plus 63 that you bring down from above. And then this would be plus 63. And then that would be 63x plus 63. But you draw a line and change the signs, and they would all cancel. After the big fat zero as a remainder, so that's happy days. We're going to take the quadratic aside. Now, you use the minus b. You guys are never going to... I'm struggling, but I'm stubborn. So, and also this isn't my leaving cert, so it's okay for me to be stubborn. You guys can't be stubborn, right? Before you get all excited and be like, oh, well, Graham, you said. So technically, this one, what would it be? 2x. This would be x. It's looking like 9 and 7. Yeah, because you do 7 and 9 are what minuses. Because then that's minus 14 minus 9. Yup. And you get x equal to 9 over 2. X is equal to 7. So again, I'm skipping a few lines because I'm assuming you nerds are going to do the minus b formula there, because you better. And oh look, there's the other two values of x. So those three, the 9 over 2, the 7, and the minus 1, are your three values of x for which fx is equal to 0. You could check your answers by just literally subbing them into the original cubic and just seeing if you get the answer correct. I probably should have said at the start that if you wanted to try that yourself, just pause it, but I'm hoping you're all big boys and girls now. You'll figure that out for yourself. This guy, now this one is a bit more flair to it, because you notice it's an actual question that it's just kind of tied into. Oh, now, sorry, I realize this question isn't actually exactly what I wanted. I wanted the part 2 or part B, but I can just tell you what it is. So in this question, right, this was in the Leaving Cert a couple of years ago, where they said, given that f dash x, so it gave you a graph, cuts the x-axis at a, b, and c. They told you what a was. They said f dash x is equal to this, show that fx is equal to this shit. Now what I'm going to do here is not factor theorem, it's just to explain what part I is. I don't think I should really, but it would feel weird me just being like, ignore that, we're just going to go to part B. But what you'd have to do here is you can skip this if you're only looking for factor theorem. How about that? Skip part I, just skip to part B or 2 or whatever. How do you turn f dash x into fx? Well, if you turn fx into f dash x, you do it by differentiation. You do it by doing your dy dx or f dash x. So to go the other way, you have to do integration. So they're basically saying integrate 6x squared minus 54x plus 109 dx. Don't forget that always has to be there, because it's like these two are like brackets, they have to be there. I did the whole thing in calculus, you can see it. If you integrate this, it would end up being 6x cubed over 3 minus 54x, I left out the 4 of course, 54x squared over 2 plus 109x plus a dirty big C. And the reason why that is because there were no limits. So don't forget, if there's no limits, you have to leave it as if there's just a constant chilling at the end that we don't know about. I left out the x on the 9 there as well for some reason. Did I just rub that out? I can't remember. There should have been an x on the 109 and the plus C. Now that is what my interpretation of fx is. Now they were nice here enough to give you this, so we know that it should be a minus 126 at the end. But if we just do on the integration alone, there's literally no way we would know that. But what we do know is, we know one of the points that's on the line. We know one of its roots is going to be at 2, 0. So, like we said earlier with a root, if you sub in the x value of 2 everywhere you see an x here, we should get a 0 here. If it's a root or a solution, that should happen, because that's where it crosses over the x-axis. So, what I can do is I can say, well, if I sub in everywhere I see, because 2 is a root, everywhere I sub in, or everywhere I see an x, I sub in a 2, I should get 0 as an answer. And I won't, but that's where we kind of use the knowledge that it should, so we know it should be equal to 0. We should be able to write that equals 0 at the end. We do that out, we're going to get 16 minus, what is this, minus 108 plus 218 plus c is equal to 0. That is going to be 110, 80, 94 maybe? That's going to be 110 take away 16, I think so. No, I've done something wrong there clearly, because c I'm getting is equal to minus, or is equal to 94. What did I fuck up? Just some numbers. I imagine 4 times 27 is 80 and 28, which is 120. Then, obviously I fucked up. Don't go with... Okay, hang on. I'm going to pause it and figure it out. Hang on. So it turns out your boy was minus in the 16 instead of adding it. So that was just me being stupid. So what I was doing is I was saying 218 take away 108 is 110. And then I was taking away 16 instead of adding it on. So 110 plus 16 should be 126. And then you bring it over and make it a minus. My apologies, but you hopefully will pretend I did that on purpose and we can use it as a learning lesson where even I can mess up the numbers. Use your goddamn calculator in your exams, please. Here it was okay because I could pause it, and by the magic of like editing and shit, I could maybe make it that you wouldn't even see me making that mistake. I'm not gonna do that, I'll be honest with you. I know for a fact I'm not gonna bother my whole. But that's how you would do part I to that question. But the reason why I pulled this one out when I was looking at the things is because I'm going to look at part 2. Now, I didn't write it down, but part 2 says, now, what are the other two roots of fx? So that basically means, if this one is 2, what would b and c be? Now, we know both of them are going to be something in 0. We just want to know what that something is, right? So they're always going to be something in 0 because the y value is going to be 0 on the root because it's where it crosses over the x-axis. And our job is to find the other two roots. But it's a cubic. They've asked you to find the roots. That's factor theorem. Let's go. So, we already know x equals 2 is a root. It was kind of given to you in a weird disguised manner. But that means we can change it to its factor form of x equals minus 2. Or x minus 2 equals 0. I'm going to be honest. I'm kind of afraid I've done videos. I'm starting to repeat the videos. I've just lost track of what videos I haven't done. And I have the fear that I'm going to be doing this and I'm going to post it up and you're going to be like, why do you have 2 videos on, factor theorem? And I'm going to actually lose it. What little I have left, I suppose. But we're going to write your boy in here because, again, it just follows the same pattern. It is just factor theorem in disguise. They gave you a cubic, asked you for the roots. This is how we do it. They gave you the first one again, but again, that was also in disguise because they literally gave it to you on the graph instead of actually saying explicitly x equals 2 is a root. But again, a root is just where it crosses over the x-axis, so that's what the 2, 0 is kind of indicating. If we do the division, again, I'm going to just hopefully glide through it without fucking things up. But we saw I am capable of fucking things up. That is, draw a line, change the signs, cancel them out. Minus 23x squared. Plus 109x. Then that would be minus 23x minus 23x plus 46x. That should have been a squared. My apologies. Draw a line, change the sign. Getting that number wrong has thrown me ever so slightly. That would be 63x minus 126. This would be plus 63. Then that's going to be 63x minus 126, draw a line, change the signs, cancel 0, and then we would take the quadratic at the very top again, the 2x squared minus 23x plus 63. We would do the minus b. This looks very similar to what I just did. Am I losing it? Yeah. Okay, that's fucked me up ever so slightly. Are we getting the same answers? I don't know. Maybe I goofed up the numbers there and somehow I've kind of put myself into the matrix or something. I don't know what's going on. Did they do it on purpose? Did I fuck something up? I don't know. Not that it really matters to you guys. You guys, they're the answers. You know how to do factor theorem now. Congratulations. We now know that the two numbers here. Now, I will say we don't know which one is B and which one is C, but we know C is the one further to the right, so it has to be the bigger one, and 9 over 2 is only 4.5, so 7 is bigger than 4.5, so that's why I put them in that order. That's how you do it. That's factor theorem. Bit spooked out there. We're living in a simulation. Got the same thing twice. Did they do that on purpose? I don't know. Did they know? I don't know. Did I fuck something up? I don't know, but just in case they're coming for me, I'm going to leave it there. Hopefully that's okay. Again, any issues, let me know. You guys can